Hello everyone, welcome back to my channel. Here I am again in front of you, and the today's topic that we are going to discuss is very interviewer's favorite topic. And if you are an experienced software engineer who is working close to the operating system, like maybe working on C or C++ or related technologies, then in your interview, you are definitely going to be asked the memory related interview question. So here are the list of topics that we're going to cover today. One is the favorite interview question, how your MALLOC works, how pointers are allocated memory, what is FreeList allocation technique. Second question is, in delete PTR from C++ or free PTR from C does not have any size information, then how does it know what size of memory to deallocate? Third question is, if we use FreeList for memory allocation, then what is the disadvantage of that technique? Why these concepts are important is because while working on the software, we come across a lot of memory related issues like memory leak is there, then program crash or system crash like issues can come. And we can solve those issues only if we understand how memory works. So hope it excites you. It excites me as well. Let's not waste the time and start. C++ program pointer.cpp. Here pointer, character pointer and two integer pointers are allocated memory using dynamic memory allocation. And then we are printing the values that are allocated. And then finally we are deleting the pointers that we had allocated some memory. In this case, for example, char star ptr1 equal to new char c. Here ptr1 is allocated memory in the stack, and the memory that is allocated for a character which is being pointed by the ptr1 is that memory is allocated in the heap. Okay, let's understand in more detail. So here in yellow, left bottom, you can see the code. And you can also see the process control block of pointer.exe. Now, the first line is char star ptr1 equal to new char. When this statement is called, ptr1, as we had said, is allocated memory in the stack. And this call to new internally makes a call to C function of malloc. And malloc actually makes some system level calls and request OS to allocate memory for a character. But the system checks the heap if any memory is already reserved, and it finds that no memory is reserved till now in the heap. So it reserves the complete page for this process and allocates memory from say location 1016 to 1024 to PTR1 for PTR1. Basically, it is the memory which is allocated to the character that is pointed by PTR1. And in this memory, the value assigned is C. So you must be thinking that the memory size of 1 kilobyte, we have only allocated an 8-bit of memory. Then what will happen to the rest of the memory? For only 8-bit of memory, OS allocated an entire page. But sadly, our hard disk is very limited size. Our RAM is also very small. Then how the then if this much of memory wastage is there, it is really very sad. But the thing is, our OS is very smart. It cannot let the wastage of this much of memory, right? So it has some technique to utilize the memory as much as it can. So for that purpose, it holds a data structure FreeList. So FreeList is kind of a linked list that points to the free memory location 1000 and 1024. Here in this diagram, you can see in yellow some memories are allocated. The header stores the information of the length of the memory that is requested, and if that memory is currently allocated or deallocated. So that yes, no information it stores, and it may store some other metadata as well. Okay, so the yellow part is the header, the blue part is the data payload, and the green part is the free list, which is the memory that is currently free and can be used for subsequent allocation. So free list is pointing to 1040 location at start of first free location and 1064 location that is start of second free location. This call to malloc of 20 byte, it does not only allocate the 20 byte of memory, but it has allocated some bytes for the header, maybe one word, or depends on how OS allocates. So this much of memory is allocated for the header, which is used by the malloc library, and the rest 20 byte is returned to the caller for this PTR variable. Hopefully, some concept is clear. And if still, and there are still many doubts, I know, and going ahead in the videos, your doubts are going to be cleared for sure. So here in our program, we had seen that memory is allocated to a character pointer. Now let's see. Now the memory is allocated to an integer, and in star ptr2 equal to new int is call will allocate ptr2 and memory in the stack. As you can see, ptr2 is allocated memory in the stack of process control block, right? Now this new int makes call to malloc to allocate the size of an integer. And malloc, as we had said, internally makes the system call to see if any page is already reserved for this process. So it finds that malloc has already reserved a page and it has the information of free list. So it in the free list information, it finds that at location 1000, the memory is empty, and 16-bit of memory that is required by this PTR2 is available in the location 1000 to 1016. So 16-bit of memory is allocated to PTR2. Then next statement, PTR3 equal to new int is called. Again, the call to malloc happens, and PTR3 is allocated memory in the stack. Now the call to malloc requests OS to allocate memory of 16-bit, and the OS checks into the allocated and the OS checks into the allocated page if any memory of 16-bit is available. So at location 1024 in the free list, it finds that the memory is available. So 16-bit is allocated. Now at 1024 location, memory is no longer free. So the free list is no longer pointing to 1024 location, and it starts pointing to 1040 location. Cool. So now let's see another important thing, that is memory deallocation. Till now we saw the memory allocation. Now we will see memory deallocation in heap. So for memory deallocation, delete operator is called in C++, which internally makes call to free in C, free function in C. So the free function in C makes the system call and requests it to deallocate or delete the memory that is allocated for the character which was pointed by the PTR1. So the memory from 1016 to 1024 location is freed, and the free list starts pointing to 1016 location. Now, the other interview question comes. How did FreePTR knew what size of memory to deallocate? Like, for example, in case of memory allocation, call to malloc was made, and here the size, requested size of 1 byte was mentioned. But in case of free, only the name of the pointer is mentioned, but what size it had requested the allocation, that is not mentioned. Then how does free know what size to free? Can you guess the answer? Yes. If you can see this diagram at the bottom, you may have some idea. Did you got it? I hope many have already guessed it, and you have guessed it right. The answer is in the header part. So, in the when malloc is request memory to the OS, it is not only the memory is not only allocated for the requested byte, but some header part is also allocated, and that header part holds the length and length of the requested memory allocation, as well as the allocated information that currently if it is allocated or not. So what all information malloc stores? It stores the header part, the data payload part, and the free list part. So when the call to freeptr1 happens, it checks into the this header part, which is used by the malloc library, and finds that ptr1 was allocated 1 byte of memory and it is currently allocated yes. So it releases 1 byte of memory to the OS. And as you can see, PTR1, which was pointing to 1032 to 1040 location, is freed, and the free list is updated. Free list starts pointing to the start of the free memory allocation, which is start of the header. Cool. So now when interviewer is going to ask you the question that how PTR knows that how much memory it has to deallocate, hope that you will not get afraid and you will answer him immediately. And all the best. So it was so simple, right? Didn't you find it very easy? That how memory allocation and deallocation works in the operating system, and still we were so afraid to understand this concept. Yeah, it is so actually a very easy and simple memory allocation technique. There are other techniques as well. But this is a simple technique which is used by some simple application where a full-blown memory allocator is not necessary. So every easy thing comes with some disadvantage as well. So let's see the disadvantage of free list memory allocation. If the reason are variable size, then it has to search for a reason that is large enough. This search can be expensive. We all know that free list stores the free memory in the form of linked list data structure. And we also know that searching a free memory in the linked list requires is very expensive. So that search is going to be expensive operation in case of free list memory allocation. Next point is external fragmentation. Suppose in this diagram of one page from the heap, you can see that it is almost full. There is very little space empty at 2000 location and some other location. Now, suppose that memory is freed for PTR1 and PTR2. So now 2 bytes of memory are available at location 1000 and 1032. Okay, free list is updated and free list points to the start of the header of the free location. Now a call to malloc is made to allocate 4 bytes of memory. Now 4 byte of memory cannot be allocated in this case because the 4 byte of memory is not free in continuation. And you can see 1000 through 1016 is free, but 1016 to 1032 is occupied by the header, and then 1032 to 1048 is free. So 2 plus 2, 4 bytes are free, but those are not free at one location. So that is the problem of external fragmentation. Next thing is coalescing. So, but suppose if this 2 byte of header, which is currently not allocated. So it is not of much use. So if we coalesce this part also, and then entire memory from location 1000 to 1048 is available. So that is the concept of coalescing, coming together to form one mass or a whole. If this much of memory is available, then it is around 8, 6 or 48, means 6 byte of memory we have, and the allocation malloc 4 requires the allocation of only 4 bytes. So that is easily possible. But it would have solved our problem. But the thing is, coalescing is not automatically possible in FreeList memory allocation. So that's that. Whew. So that's a lot of concept. We learned about a lot of important topics like interview's favorite question on memory, like how newer malloc work, how pointers are allocated in memory, what is FreeList memory allocation technique. So next time the interviewer is going to ask you this question, you must be prepared to answer it. Next question was how delete PTR and free PTR knows how much memory to allocate. Do you remember? Header part, right? And then the disadvantage of FreeList memory allocation. So if you are going to explain him that yes, malloc uses the FreeList for memory allocation and deallocation, the next question they are going to ask you is, do you think any disadvantage it has? And at that time, you are going to tell him external fragmentation, right? Lot of memory. But I had tried my best to present this concept in as easy way as possible. And I hope that you enjoyed watching this video, and hopefully it added some value to your knowledge. And if it has done so, then please like and subscribe to my channel. Hit the bell icon and stay connected. Bye-bye.